I'm trying to go through a paper. So this is a paper on environmental health risks and housing values evidence from toxic plant openings and closings. So they're trying to look at the effects of pollution associated with the opening and closing of toxic plants nearby on housing value and health, infant mortality, health on kids. Let's just focus on the housing value regressions. So what they've been doing is trying to place housing price or infant mortality, infant birth weight on the left-hand side of the regression and put the toxic plants, the dummy variable, an indicator variable of whether or not you have a toxic plant pretty close to you on the right of the regression, and try to explain how much toxic plant explains variation in housing price. So what kind of endogeneity issue could you come up with if the regression is simply about housing value and distance to toxic plants? Well, there might be selection, right? So imagine what kind of communities will a toxic plant locate at. So most likely, if someone wants to place a toxic plant in a rich neighborhood, they will face much stronger pushbacks compared to when they want to place a toxic plant in a relatively poor, less well-off neighborhoods, right? So it's, I guess, part of this reason is political. Like if these are rich guys, they have connections, they have ways to block this proposal. Talking about communities with poorer households, they're less capable of, let's just say, they're less capable of changing the decision of placing a toxic plant near them. And there might be that the proximity to toxic plant is associated, is correlated with proximity to a whole load of other things, such as proximity to transportation junctures, to other things. Basically, you want to put a toxic plant near transportation junctures. So their empirical approach to deal with the endogeneity issue is that they're to some extent adopting the difference in differences approach. They're looking at how the changes in housing value responds to the opening and closing of plants. That is basically conditional on the fixed characteristics of the neighborhood. How does the entry of a new toxic plant affect its housing value? So this the story of richer households being able to shut housing plants, toxic plants away, as long as these places remain rich. The composition of neighborhoods don't change much before and after the opening or closing of the toxic plants. You can imagine the entry is more of a choice of time rather than a choice of communities. Right? So can you think of time varying factors affecting both? So if we are able to control for the time invariant factors that determine both housing value and the availability or the existence of plants. And here, by looking at changing or entry or exit of plant, we're able to single out, we're able to kind of isolate all the constant factors. We just look at how our new housing plans lead to new changes in our study. What might be your endogeneity concern in this new setting? That is basically saying that are there any other events that correlate with the entry or exit decision of a of a toxic plant, and it should be changing over time. That the events also affect housing price. The factors that determine closing or opening of a toxic plant near these neighborhoods, could that also be correlated with housing price in this neighborhood and in this city in general? Can you think of any stories?
I was thinking, I'm not sure, about, let's say, probably about an energy consumption increase that asks for using, let's say, nuclear plant to, that takes too much time probably.
How would that explain this?
I mean, if you, let's say, use carbon production, extraction in an area that causes, well, not toxic, but still, I mean, increase of pollution of a nearby area, cause of increased need of energy in the energy production in the area. I don't know if this could be related to the increase of opening of new carbon extraction plants. I'm not sure.
I'm not sure I can get your idea, but one idea you might have is the opening of the plant itself is offering jobs. Like imagine the plant is hiring a lot of workers. Their workers want to live near their workplace. There might be extra demand for housing nearby. Right? It could be that the plant is bringing jobs. The plant is like suppose they hire a lot of workers. These workers need restaurants. These workers need stores. They
You mean water treatment plants to for increase of demand? I don't follow. Sorry.
sorry, my computer just crashed. So back to the point, I mean, like one endogeneity concern would be the plant itself. The plant is a bundle of jobs, demand, and pollution. GDP jobs, GDP, and pollution. It might be that the other factors are not also explaining variations in housing price. And how do we isolate out the effect of pollution? Pollution is specifically associated with these plants. And another idea might be just the plants gets closed down because there's some economic factors. There is kind of overall economic downturn in this area, in this specific sector, in this area, that might also affect housing price. Right? So imagine all the plants closed down because of, suppose we're talking about Detroit versus New York. We would see a lot of toxic plants closing down in Detroit because of the fading of specific industry, specific car manufacturing industry. Meanwhile, the housing price of Detroit will decrease, not because of pollution associated with these car manufacturing plants, because it's a general economic downturn, a general demand-driven factor that's affecting all the housing demand for Detroit houses. Can you think of any fix to this problem? Imagine that you have the exact location of these plants, and you have very detailed housing transaction data. You get the data from a real estate agents. They're going to provide you with the address of all the houses and their selling price. Can you figure out any fix to this problem? A lot of the times, how much we could address an endogeneity issue depends on what kind of data we have. The more resolute the data are, the more detailed information we have, the higher resolution we have, the more likely we can solve the endogeneity problem better. So in this case, the authors are claiming that the pollution effects of housing, the pollution effects of toxic plants on housing price is very local, right? The pollutants were carried from several miles away at most, so the decay rate of pollution transmission was pretty high in distance, but the housing demand effect kind of extends to a much larger geographical area. Like, imagine your workers, the new houses, the new plant brings in more workers. The workers might be willing to pay for houses within 30 minutes commuting time anyway in these areas. But he or she doesn't have to live within 1 mile to the toxic plants. But pollution effects would appear much more local than the other kind of demand-driven effects. The fact that the plants bring in new workers, these new workers want more services. You can see that new services don't have to be concentrated very close to the plants themselves. They can be concentrated closer to where the workers live. Or if there are economic boosts, economic downturns, the kind of Detroit car manufacturing effects. It applies more universally across Detroit. It doesn't have to apply very closely to regions at very close proximity to toxic plant itself. So what they do is, in the differences approach, they choose their control group carefully because you know the exact coordinate of toxic plant as well as transaction of houses. You know where these houses are. They are able to use the housing properties within 1 mile as a treatment group, and from 1 to 2 miles as control group. The idea is that pollution effects dissipate pretty quickly after 1 mile, but the other effects are the commuting, induced demand. They would still exist at a 2 mile range. If you're a worker, it doesn't hurt that much for you to leave 2 miles away compared to 1 mile away. So of course, you can argue about that. I guess in the U.S. it's fine. Everyone drives fine. If a lot of these people work to their workplace, it might be an issue. Do you get these results? What they're doing is to compare houses within 1 mile to those between 1 and 2 miles to a specific toxic plant, and the second difference comes from close or opening of the plant.
Could you also have a selection bias when you're choosing your control group?
What kind of selection bias is that?
I'm just thinking more generally. Like I could maybe pick a control group that could say favor the results I'm maybe expecting to receive.
If the selection is going to kind of invalidate the results, you need the selection to be very local. You're saying that I'm avoiding. I will carefully choose the location of my plants, taking consideration of houses within 1 mile of range, and from 1 to 2 miles, and just completely ignore the impacts for. It could be. Right?
All right, it's just more of a general question.
Yeah. It could also be that maybe these properties. I don't know. It's in general. It's hard to raise kind of economic forces. Any economic force that's operate within 1 mile and doesn't operate from 1 to 2 miles in proximity to a toxic plant apart from the effects of pollution. That's what they were claiming. So the way you do this is you run a regression of your outcome. I suppose this is housing price, toxic plant J. I think B is distance range B, and P is time P. So the distance range is maybe 1 for within 1 mile and 0 for 1 to 2 miles. And they are able to the outcome of the coefficient of interest is 3. You want to look at you want to focus on the interaction effects on opening plus being closed. Right? But the difference in differences estimate always comes from the interaction term. So these are two first differences, and this one is a difference in differences. Just don't need to remember the equation or anything. So I'm trying to explain the equation to you, just in case you want to read the papers. And these two terms are fixed effect. They're controlling for time fixed effect and the let's say the Planck's fixed effect. Just ignore this. These are unobservables. The identification strategy or the implementation of this empirical approach relies on your belief that these unobservables and the interaction of these two terms are not correlated, controlling for Planck opening and being itself. So to validate the idea that the pollution effects reduces, decays pretty fast in distance, what they've been doing is they look at toxic plants and monitors and in pollution, air quality concentration, air pollutant concentration monitoring stations to these toxic plants and look at how pollution itself corresponds to distance. So whether or not air quality monitors within 1 mile to toxic plants are likely to capture higher readings than similar monitor within 1 to 2 miles. And the answer is yes. So the level of air pollution pretty much decreases steadily, and the difference, the proximity to toxic plant doesn't matter anymore over 1 mile. So that's this is the main regression table. So they are able to do this. You can cut these treatment rings differently, right? So what they've been doing is they use 1 to 2 miles as a control. For treatments, they could use 0 to 0.5 miles, 0.5 to 1 miles, 0 to 1 miles. So this is this is going to be the main specification, but they can test different smaller narrow rings as well. So what's the information takeaway?
If I understand properly, there is a negative factor, so it means that the price of houses decrease a little in this area due to the plant.
Yes. So to explain the coefficient, what you should say something is compared to a house that locates within 1 to 2 miles to a toxic plant, the fact that you locate within 1 mile to the toxic plant means that when this toxic plant opens, your housing value suffers 3% 3% more decrease compared to your neighbors within the 1 to 2 miles in response to the plant opening. And so that's the idea. It's a difference in differences. You are exploiting the plant opening and closing. So these are some events. So the plant itself is opening you can think of plant closing as a reverse effect of plant opening. When a plant closes down, if you're within 1 mile to the plant that closes down, your housing value will appreciate by 3% more than a house that locates 1 to 2 miles to the same house. It's a little bit convoluted, but you should be able to explain this. So reversely, you could be looking at the effects of opening and closing separately. And what they are finding is that the sorry, this is the first way. You can ignore the first way. It's a hedonic approach. Hedonic regression is just focused on the housing price. And another thing to observe is that the effects decay in distance, right? The effects from 0 to 0.5 mile range. The effects are quantitatively larger than the effects over 0.5 to 1 mile range. So if you're very, very close to the plant, its opening has a larger impact to you in terms of housing value. So it's indeed capturing very precisely the exclusion. So they could look at dynamic effects. So suppose we don't just focus on the effect of opening and closing. We focus about years before opening and years after opening. So I guess the lesson would be that when the plant opens, the effect is more instant. You have the housing units nearby experience depreciation in value almost instantly after the fund opening, and kind of recovers a little bit or stays at this level. But for a fund closing, you don't have an instant effect, but the effect kind of gradually accumulates over time. Can you think of an explanation to these different dynamic patterns of opening and closing?
Well, for the opening, we can think about people are a bit afraid about the effects that the toxic plant will have on them.
Yes.
So it will cause people to be afraid, so there will be a decrease of the value,
Yes.
and the spread will change, will be reduced as long as we reach the time of opening, because the effect maybe will be more certain. And after a while, the price will increase again, maybe because of inflation, maybe because people get used to, and they just care less about the toxic effect.
Okay. So, do you have anything to say about the gradual effect for compounding?
Yeah, they have an increase after 4 years. The price is going to return to the original one.
Yes.
So this could be an explanation.
Okay, yeah, I agree with you. I think the instant effect of opening is more like the opening of the pump is a much more visible event than the closing of the pump in nearby neighborhoods. You see a new pump just open in your neighborhoods, it's a bigger shock to you than an existing operating pump ceased operating. You might just don't know that the pump nearby ceased operating as you carefully observe its chimney, right? It's smokestack. Or you can say that for plant closing, even if the plant closes, its environmental impacts probably still linger around a little bit. They might have some residue pollutants, especially ground pollutants around. So that could also be part of the channel.
Could you also argue that it has to do with supply, maybe? So maybe when the plant first opens, people are selling their houses within that immediate 1 mile radius there just because they don't want to be close to it, so that increases the supply. And same thing for plant closing. People see that, okay, now there's no pollution here, so I'm going to buy this house here. I'm fine buying this house here, so the supply decreases a little bit.
The supply effect is interesting. So you might say that I think that supply effect should be something that gets captured in this problem, because the fact that people are willing to sell their price at a lower price means that they don't like pollution, right? The fact that people don't want to buy the house at a medium price means that they don't like pollution. The fact that people are willing to sell the price at a low price, sell their house at a low price when the new plant opens means that these guys hate pollution. So both demand and supply responses are driving the results. Yes. And are there any critiques against hedonic approach? So do you think the hedonic pricing approach will capture the valuation of suppose it's done empirically with those endogeneity issues as good as possible? Are there any other issues apart from endogeneity issues that make you a little bit suspicious about hedonic pricing approach? So I can share with you some of my thoughts. So first is the hedonic approach pretty much captures people's subjective belief of how damaging pollution is, or how damaging toxic plants are to their welfare, right, to their benefits. So it has something to do with information as well. So if you know the toxic plants near you emits toxic air, creates air pollution, and you know air pollution hurts your health, it makes you unhappy, it makes your life worse, you are able to conduct these responses of either selling your house or avoid buying a house in this area. But if you don't know either of these channels, you don't know that this plant is toxic, or you don't know that pollution is bad for your health, or you don't know exactly to what extent the toxic plant hurts your health or makes you creates these additional problems for you. If you don't have a full image of the extent of this problem, you're likely to under-respond. Right? The price effects are not going to be capturing the full cost of pollution. That's one issue. The other issue is that if here we're kind of relying on the fact that the opening and closing of toxic plants are only bringing differences in pollution. But imagine that the housing basically you have all these moving in, moving out responses of residents. So what kind of people tend to move out because of pollution in terms of their household characteristics? Like people who care more about pollution. If you think that rich people care more about pollution than poor people, rich people are more likely to move out of these neighborhoods because of pollution, because of toxic plant. And poor people are more likely to move into this community following the opening of a toxic plant because of lower prices. But if you imagine this swinging story going on, then after a few years, the valuation is not just about whether or not these neighborhoods is close to a toxic plant, but more about the composition of neighborhoods, like how rich your neighbors are. If you value the fact that if you value rich neighbors, in some extent you think that your welfare is higher if your neighbors are richer, you are willing to pay more for a house in a rich neighborhoods. Here, basically, the toxic plant entry is going to make the neighborhood in general poor. If you think that rich families tend to move out, poor families tend to move in. If you have this sort of swing going on, maybe within a few years, the variation in housing price is not just capturing pollution difference, but the differences in housing in neighborhood composition, right? So these are all practical issues associated with hedonic approach. Of course, you can deal with all these issues. You can say I can just control for the neighborhood composition as much as possible. People are saying that there are things you can't observe and can't control about neighborhood composition, right? Not so much for hedonic pricing and total cost method. I hope these approaches are clear to me. These approaches are clear to you. Any other questions? If there are no questions, we have.
I have a practical questions.
Sure.
About the multiple, I know how to do a regression for one parameter. For multiple parameter regression,
Yes.
Do we have to need, unless we use Excel or some software that does it for us?
Yes, for this, you need some statistical software. You need, we use data, you can use eViews or other statistical SPSS, all sorts of statistical packages for running multivariate regressions. I guess the purpose of this class is not trying to teach you about exact technical details. It's more about trying to brief you about empirical design. And if you're interested in the technical details, there might be other courses to take, or you can learn the software for yourself.
I was just curious about what we need to know for the assignment and the final exam about this.
So I don't need. I won't ask you to run regressions in the class if you work in exam. If you work in exam, most likely I will raise the topic. Like suppose we are studying the problem of economic pricing, and we have a context of housing price and pollution. Just tell me, describe in this specific context what would be your endogenic concern. And if I'm just giving you examples of, maybe I'm citing other papers, how authors of those papers offer a solution to this empirical approach, like what empirical approach is this guy employing. So in this example, suppose I'm saying that of this 2015 toxic plant paper, what empirical approach does it employ? We were just saying difference in differences. Right? Then I'm trying to say, why do you think difference in differences work here? You could raise the point that basically they're choosing this control group, which seems to be really comparable. The treatment group and other empirical concerns you have will be cancelled out, or will be parted out in this design. And maybe I will write something in the end, like giving you some numerical examples about raising housing price and ask you how much would your evaluation of this toxic, of this like environmental disamenities associated with this toxic plant be, right? It's usually like that. So as long as you can follow my examples in class, all these papers, you think critically about the approach, and you have some basic understanding about why we're using this empirical methods, what kind of issues are we dealing with, you should be fine. I won't ask you to do any specific task in the exam. You will be able to see this in your problem sets, or I will be basically I'm asking you all these questions in class about what other empirical issues, what other endogenic issues could you think about. I could well be asking all these questions in the exam, just citing this paper or citing another paper. Right? Now I'll ask you the regression discontinuity. Why do we need a sharp jump to employ the regression discontinuity in this design? Obviously, if there's no sharp jump, then there's a continuous change in this variable. It's not telling you anything. The fact that going north is associated, going north by 1 degree is associated with more dust or less dust. Can't just be pinned down to pollution itself. It could be pinned down to all these other factors associated with latitudes or latitudes. So you basically need this sharp jump for cities with very similar latitudes to identify the gas pollution on health. Right. Or I will just give you a question as suppose winter heating itself has health benefits. That's we overestimate or underestimate. You need to follow these discussions. So if you're able to follow these discussions, you shouldn't have any problems. I guess the purpose of these whole part is to expose you to the field where people try to use data to answer policy relevant questions, and how are these methods implemented, and what are the limitations of these methods? All right.
Thanks for explanation.
Okay. So let's have a video here about travel cost methods. Now we can. It's a real example of the travel cost method, and we can. Can you see my screen?
The swimming area, lots of grass for picnic, and relaxing forest with a trail to explore, rocks for jumping, and it's free. And you're willing to pay for the area and experience just like you would for an amusement park or some other recreational activity. But if the rent is free, then how do landowners really know how much they should be spending protecting and maintaining the area? While nature doesn't charge you for a beach the same way you're charged for an amusement park, there are some indirect costs involved in these things. You have to spend money getting there, plus fare, fuel, car upkeep, and you'll have an opportunity cost on your time. These are the economic costs of travel. So people treat travel costs the same way they would treat a ticket price. And they feel they're getting at least that much value from the experience. Those who have to pay the higher costs, people who live far away, will probably go less often than the people who live closer, for whom it's cheaper to get to than to do something like we did in the previous video, where we took the price and consumer data in past years and used regression analysis to build an equation from that. We do the same thing here, but using travel costs instead of the cost of the product or service. Something we need to think about though. Let's say this is their travel costs. That's what we're going to assume is the benefit they're receiving from the area. But some people might enjoy the trip. It's not just a cost to them. And otherwise people may be doing other things. And this is just one stop on the trip. Like the weekend grocery trip that is always accompanied by a visit to the lake or something. Okay, these travel costs they're trading may be being traded for more than just the recreational spot. They may be split among the enjoyment of driving or other activities, which will model our analysis. So it depends a bit on the specific kind of analysis we're doing, but the general information that we want from people is how far they travel, how many people are traveling together, and how they travel, so we can know their travel costs per person. We want to know how often they go. We want to know if they're doing anything else on the trip, their income or other demographics that affect demand. And otherwise, we want to know how many people use the site each year and whether or not there are substitute sites in the area. If we can collect information for this stuff, we can use regression analysis to try to build the relationships between the stuff and the amount the area is used or the demand. Then we can play with an entrance fee, tweak the costs people have to pay, and see if bringing in money that way can be efficient. Or if we also gather information on what people do at the location, see what portion of people are coming for swimming or hiking, then we can predict how the value of the location will change with the potential environmental damage, or see if it's worthwhile to invest in improvements. Some researchers looked at the value of recreational fishing of abalone along the coast of California. Conservation strategy fund researchers actually. To fish abalone, you have to be registered, and you're expected to keep records of where you catch the abalone. So they just drew from that to find the population of the fishermen and where they go. Then they did a phone survey of a subset of the registered members and used them as an estimate for the rest. There were about 50 diving spots, and they factored in the presence of public bathrooms, boat launch spots, algal bloom events, parking, and ease of access. So they could model these other factors that influence an angler's decision to dive there, find out what people like and why they would travel far to different spots. To find the actual travel costs, we would find the distance they've traveled and then multiply it by the price of driving. Which will depend on the price of fuel in that location. AAA has a tool that can make this really easy. Then calculate the opportunity cost of their time. There are different standard ways of doing this. In the abalone study, they took people's wages and divided it in half. If we don't have data on income, maybe we take the average wage of their zip code and divide that by half. In the United States, at least, they keep census data on people's wages. We could also use this to value some goods. If people have to travel to gather water or other materials, there could be travel costs involved in those. But this method is mostly used for recreational value. In the next video, we're going to look at housing prices as a way to value ecosystem services.
All right. I feel like these set of videos are pretty nice. These guys can explain things much better than I did. They have many videos. I'm not showing the hedonic pricing one. Maybe I can show you the hedonic pricing one. I find the travel costs were better than the hedonic pricing one. If you're interested, you can follow these.
The environment and economic development.
We still have 5 minutes. I guess we can take a look at it. Not planning to. I'm not planning to start the next session, so let's just take a look at the economic pricing video as well. In case you would like a second person to explain all this concept to you.
This environmental valuation method tries to quantify the value of ecosystem services by examining housing types. If people value parks, lakes, nice views, if they dislike pollution, then presumably the value of these things will be reflected in houses that are closer to or have these characteristics. So the idea is if the price of a house is influenced by the characteristics of the house, we can collect information on prices and house characteristics, like the number of rooms and the distance to amenities, and then use regression analysis to build a function that can predict how the value would change in the absence of the environmental service. So this method is best for estimating ecosystem services that are captured in housing prices, like the value of being close to a wilderness area or park, scenic views, and the negative effects of pollution. This method is nice because it directly observes people's behavior. Housing prices are